All right, in this video, we're going to start solving oblique triangles, which are triangles that are not right, using the law of sines. So we'll learn a couple different ways to solve non-right triangles. And the first one we're going to learn is the law of sines. So first, we have to know, can you make a triangle given three side lengths? So if you're asked to solve a triangle, meaning find all the angles and sides, if you're given three sides of a triangle, all right, doesn't necessarily mean you can make a triangle. So I want you to take a minute or two to see if, write in the chat, if there's any set of sides here that can't make a triangle. All right. So we got A, B, C, D, E, and F. Those all represent three sides of a potential triangle. If you see a set of sides that can make a triangle, I'd like you to right now put it in the chat. Now, I may have kind of misled you with what I said. So write either, like with your answer, right? It can make a triangle or it can't make a triangle. Because I realized that on the screen it says, can the sets of numbers represent a triangle? But I said, are there any sets of sides that can't make a triangle? So just to be clear of what you're saying, if like, right, C can't make a triangle, like D can make a triangle. All right, so let's look. Oops. All right, so this is called the triangle inequality conjecture. All right, so if I had a triangle with side lengths 7, 9, and 12, I can make a triangle. All right. Now, if I were to shorten these so that this side was 6 and this side was 6, all right, and imagine that the side lengths that are 6 are like a drawbridge, and 12 is like the width of like a river that this bridge is going over. All right, so if you ever maybe been down the shore and you get caught at a light and the bridge goes up and like a boat goes underneath, like that's just what I think of here. So if you had a bridge like that where each side was 6 and then the third side was 12, like the width of the river, all right, that wouldn't make a triangle, because as soon as the boat would go underneath, these sides would break apart. All right, 6 plus 6 equals 12 exactly, which means these two red and green segments are only going to meet when they overlap that side completely. But once that you come up to make a triangle, they're not long enough to reach each other. And if I made these side lengths any shorter, all right, we would have the same issue. But if I made it so that these two side lengths add up to be more than the third side, all right, so if side B and side C add up to be more than 12, hence why it's called the triangle inequality conjecture, like a greater than is an inequality symbol, all right, you can make a triangle. All right, but let's say I made this 5 and 5, and this side was 9. All right, that would make a triangle because 5 plus 5 is bigger than 9. All right. But as soon as I made this side 10, so that the two other sides don't add up to be more than the third side, they're not long enough to reach each other. All right, so in order to make a triangle, you need to make sure any two of the sides add up to be more than the third side. So if you want to now make a new guess in the chat, feel free to do so. If your first answer, if you were fine with that, then you could just leave it there. But if you now want to make a change, all right, please comment that in the chat. All right, so for A, no, you can't make a triangle with those because 12 plus 24 is not greater than 36. All right. B would be yes, because if you add the two smaller sides, they do add up to be more than 32. All right. C would be no, because 20 plus 2 is not greater than 25. all right? D, you can make a triangle, right? It'd be like an isosceles triangle where like this side is 24 and that side is 24. So this third side could really be anything greater than 0. So a way to check that with the inequality conjecture is to do the two smaller sides. It's like 16 and 24, and that adds up to be bigger than 24. All right, right here, no, right? Because 19 plus 19 is 38. That's not greater than 41. All right, and then the last one, can make a triangle. Yes, because 60 plus 25 is more than 61. All right, so when you're solving triangles, you first want to make sure that you can make a triangle. All right, next thing I'll look at is cases. So this is just a little skill I want you to have, because when we talk about, like, will you do the law of sines? Will you do the law of cosines? Will you do the ambiguous case? It depends on the case that you're given. So the cases are the same as the triangle shortcuts that you learned for congruence back in geometry, like side, 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 angle, angle, side. All right. So you want to know the case that you're given so that you know what process to use. And for law of sines, we're going to use that when it's angle, angle, side, and angle, side, angle, which I'll talk about later. First, how do we know what the case is? All right. So what you do is draw the tiny picture. So when you draw your tiny picture, it could look like an equilateral triangle, even if it isn't. All right. And the angles always get uppercase letters. The sides always get lowercase letters. Right? If you ever think of the Pythagorean theorem, a squared plus b squared equals c squared, if you think about when you read that, a, b, and c are usually lowercase because they're sides. And we usually see like the sine of a equals like opposite over hypotenuse, like that's usually uppercase because it's an angle, all right? Something that you may have never noticed. And then the sides with the same letter are opposite the angle with the same letter. So if that's angle A in the picture, then that's going to be side 6. All right. And then this side length would be 14. And this side length will be 12. So every time we solve these, we want to know what the case is and what we're given. So this would be side, side, side. All right. The next one, we're given two angles and a side. So again, the picture doesn't have to be perfect. It could just be an equilateral triangle. So it's like D, E, and F. All right, so this would be 16 degrees, angle D. This would be 24 degrees, and give yourself more room than I'm giving myself. It's hard to draw on this iPad here. All right, and then side D would be 16 as well, but 16 in length. All right, so what's the case here? Well, you're given two angles and the side. Now, the side that you're given is not in between the two angles that you're given. So this would be considered angle, angle, side case. All right, not angle, side, angle. If you wanted to say side, angle, angle, that's the same thing as angle, angle, side. I like to use angle, angle, side because those are my initials, AAS. But side, angle, angle also works. All right, I think you get the hang of this, but just quickly do these other two. So G, H, I, doesn't matter where you put them. All right, G would be 16 degrees, I would be 24 degrees, and H would be 16. So side H is across from angle H. All right, so that would be, you're given two angles and a side, but now the side is in between the two angles. So that would be angle, side, angle. There's only one way to write that. All right, and then last but not least, you get J, K, L, all right, 16 degrees, 24 degrees, and then L is across from side L. So 16 would be right there. All right, so this would be side, angle, side. Okay, so when I say side, angle, side, angle, angle, side, 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 I'm just referring to the case that we're given. And that's important to know because if you know the case, then you'll know what process to use, whether it's law of sines, law of cosines, or we'll also learn something called the ambiguous case. All right, now, what is a law of sines? If we were in a normal class, I would put you in groups and work through this for like 10 minutes, but we're not. So I'll just highlight the important parts of this. All right. Let's say we have to solve for x here. Now, this is not a right triangle, but if you draw the height h on this one bigger triangle, you create two right triangles. All right, so this is the bigger triangle. And with it, if we draw the height, we create two right triangles. And we know that with right triangles, we could do SOHCAHTOA. So if we take the sine of 28 degrees, all right, and use what we already know, we know that's equal to h over x. All right. Now, if I just isolate h for a second by cross multiplying, I get h is equal to the sine of 28 times x. Okay, we'll come back to that later. Okay, now if you look at, actually I like that there. If you look at the other triangle, and we did the sine of 62 degrees is equal to h over 17.5. Now what I'm showing you in the end here is ultimately what I just want you to understand where the law of sines comes from. You're not going to have to do all these little steps. Just keep that in mind. But this will help you understand why the law of sines works. All right, so we cross multiply and we get h is equal to the sine of 62 times 17.5. Okay, now because of the transitive property, because we know h is equal to h, we could set these two equal to each other. All right, so we get, I'm going to write that up here. We get the sine of 28 times x is equal to, so that is equal to that, the sine of 62 times 17.5. Okay. Now, if I'm going to erase this so I have room. Okay. Now, if I just kind of rewrite this as a ratio, so I'm going to divide this side by x and this side by x, and that'll cancel out. Then I'll divide this side by 17.5 and this side by 17.5, and that'll cancel out. We end up getting the sine of 28 is equal to 17.5, or sorry, the sine of 28 over 17.5 is equal to the sine of 62 over x. All right. Now we could solve for x by cross multiplying. Now I could have solved for x up here without doing this step, but I wanted to do this step to show you this is the law of sines. All right. So the law of sines says in any type of triangle where you have enough information to do so, all right, if you take an angle like this angle here, all right, and divide it by the side across from it, so that side right there, it'll equal the ratio of any other angle in the triangle. So in this case, 62 divided by the side across from that, all right, x. So pretty much any time you're given enough information where you have an angle and a side across from it, and then either another angle, then you could find the side across from that, or another side, you could find the angle across from that. Right, that's when you're going to do the law of sines. All right. So in this case, we were given angle, angle, side. So angle, angle, side is one time where you want to use the law of sines. Another time where you can use the law of sines is angle, side, angle. All right. If you're given side, 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 or side, angle, side, that's when you would use the law of cosines. Okay. Now we haven't learned that yet. So for now, if you get one of these cases, you don't know enough to solve it. So you'll just wait until we know the law of cosines. All right. Angle, angle, angle is another way to order all the letters of S and A. But this, if you have angle, 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 then you don't have enough information to prove that, to find the sides. Because like, let's say, for example, I had like a 60, like an equilateral triangle, 60, 60, 60. If I was just given all those angles, I don't know whether it's that triangle or like a similar triangle that's bigger. So angle, angle, angle is not enough information to solve a triangle. And then there's also one more. If you remember from geometry, it was SSA, or backwards, ASS. Spelled a bad word. Okay. Now, we're going to spend a whole day on that case. So if you get SSA or ASS, just try to solve it with the law of sines for now. And I'll do an example of that. All right. Now, if we were to keep doing this worksheet, we would come up with like a general formula for the law of sines. All right. But I kind of just demonstrated that for you. So we'll jump right to the formula. And it is, so if you know the measure of two angles and one side of a triangle, you could find the other two sides of the triangle by using the law of sides. So in other words, what I just said before, if you're given ASA or AAS, use the law of sides. All right. People are probably writing that down. When you have access to these notes, I'll give you another, give you like 20 seconds to write that down. All right. And again, if you're not given one of these cases, the only other case that could work with the law of signs is SSA. But that's a little more complicated than just saying use the law of signs. And we're going to spend a whole day on it. But for now, if you get SSA as a case, then try the law of signs. Oops, sorry. And so here is the law of signs. So for a triangle with angles A, B, and C, and side lengths A, B, and C, where A is opposite A, B is opposite B, and C is opposite C, then the sine of angle A divided by side A is equal to the sine of angle B divided by side B, and that's equal to the sine of C divided by the side across from angle C. Right. So remember, when we draw the picture, if we put A there, then lowercase a has to be here. If we put B here, then lowercase b has to be there. If we put C there, then lowercase c has to be there. Other than that, it doesn't matter where you put these angles or sides. All right. And when you're using this formula, you're never going to use it with like two equal sides. You're just going to, solve that proportion, or solve that proportion. So in other words, if you're given an angle and side across from it in a triangle, like if you knew that angle B was like 50 degrees and you were given the side across from it was like 10 centimeters, then as long as you're given any other angle or side, you could do the law of sines to find that missing angle or side. So like if you were given that this is 60, now if you wanted to find C, you would do the sine of 50 over 10 equals the sine of 60 degrees over C. All right. And again, that's angle, side. So that's how I know to use the law of sides. All right. Let's say that you were given two sides in an angle. Let's say you were given that this side was 11 centimeters, this side was 21 centimeters, and this angle was 42 degrees. All right. You now don't have enough information to do the law of sines. All right. If you did the sine of 42 degrees, you would divide that by A. And then if you set that to the sine of B, you would divide by the side across from B. All right, so now if you set these two equal to each other, you have two variables. You have A and a B, so you can't solve that. All right, or what if you used, the other side? You said like, okay, the sine of C over 11, right? You still have two variables, so you can't solve that. All right, that's because this is side, angle, side, SAS. All right, when you're given SAS or SSS, all three sides, that's when you do law of cosines, which we haven't learned yet. So for now, you would just not solve that. All right, so let's try two examples and show you how this works. So solve the triangle. So first, can we use the law of sines? So you can use the one rule I gave you. If it's angle, side, or angle, side, angle, you can. And this is angle, side, because we're given angle A, angle B, and then side A, which is not in between A and B. Another way the way I just determined if you could do the law of sines is if I'm given a side and an angle across from it, then that means I could do the law of sines. Because I could set up the sine of 59 degrees over 350 and set it equal to any other angle, the sine of that, as long as I'm given that angle, divided by the side across from it. All right. So now I could solve this proportion here and find angle B. All right. So we're going to use the calculator to solve that proportion by cross multiplying. So I'll multiply these together first. So you get the sine of 350 times the sine of 38 equals the sine of 59 times B. And then you could divide both sides by the sine of 59. And then now I'll know what side B is. So now I'm going to type that in the calculator. Now the first thing I should have done before even doing any of that stuff was I could have found angle C right away too. So if you're ever given two angles and you have to solve the triangle, which means find all the angles at the sides, you could, if you're given two angles, you could find the third one by doing 180 minus 59 minus 38. And we get that angle right there is 83. All right. So now I'm going to go back to this work that we did and type it in the calculator. Now, unfortunately, I can't keep both things on my screen at the same time. So we're going to have just to remember what it was. There we go. Okay, so again, we're going to solve this equation. Sine of 38 degrees, so make sure our calculator is in degrees, over B equals the sine of, let me put that as a fraction, control division, the sine of 59 over 350. We're going to solve for B. Now, the calculator's in degrees, so we'll be good. And so hit enter, and it gives us a weird answer. You get 251.38. And always do like a mental check, see if that makes sense. Well, the side across from 59 is 350, so the side across from 38 should be smaller than that, but still kind of close to 350. And 251 seems pretty close to me. So that just by doing like a ballpark check, that seems to be right. If it was like 25, I would say that's a little too small to be in a triangle where the other side is 350. You know what I mean? That angle 38 degrees is probably closer to like 1 or 2 degrees. All right, now, if you don't have a CAS, again, you would solve this equation here by cross multiplying. So you do 350 times the sine of 38. Right, and then that would equal B times the sine of 59. So then you would divide that by the sine of 59. All right, and we get that answer, 251.38. All right, so right now, we know that this side right here is 251.38, and this side up here was 83 degrees. So we've almost solved the triangle. All right, now we have to find this missing side here. So we're going to do, I would always use the side and angles that you're given because you know it's not wrong. So again, we could do the sine of 59 over 350 equals the sine of 83 over x. All right, so that over that equals that over the side across from it. All right, now we're going to solve that equation. So I could just, if you have a CAS, you could just go back up here and then do the sine of 38 over B, or sorry, the sine of 59 over 350 equals the sine of 83 over C. Because now we're finding side AB, which is also known as side C. And you have to hit Control Enter. And you get 405, which makes sense because it's across from the biggest side. Sorry, it's the biggest side because it's across from the biggest angle. Because angle C was 83 degrees. All right. Now I want to make sure you know how to do this, you should know how to solve this equation here. All right. In case you don't, you're going to cross multiply by doing the sine of 83 times 350. Then that's going to equal, cross multiply the sine of 59 times C. Now if you take that and divide that on both sides, you get that same answer there. Okay. And that's the law of sines. All right, so one more example here. Now this is called the ambiguous case, which we're going to spend next class working on after the test. It's the ambiguous case because it's not clear, hence the word ambiguous, if you can make one triangle like this. Now, you were going to learn that when we have this case ASS or SSA, that maybe there's one triangle, like as it looks in the picture, or possibly there are two triangles. Like you can make one triangle like this and another triangle like this. All right, if this side is the right length where it could hit here and here. Or maybe this side isn't long enough and you can't make any triangles. Where if this side wasn't 250, if it was like 50, then it wouldn't be long enough and it wouldn't be able to reach the other side to make a triangle, like we talked about at the beginning of the lesson. So when you have ASS, it's not clear that you can make exactly what right triangle, like it is when you have side, side, side. Now, until we learn about the ambiguous case, if I give you ASS, so just for today, really, you can assume that there's one triangle that you can make. But I want you to understand that the reason why in the beginning of the notes I said law of sines works for AAS or ASA, and I didn't include ASS or SSA, which is the same thing. ASS and SSA are the same thing, is because it's ambiguous. It's not clear if you can make a triangle. We'll talk about that next time. But let's say we figured out that we could make exactly one triangle. Now, how would we solve it? All right, we would do the same thing. We would take the sine of 69 degrees over 250. And then since I'm getting this side, I'm going to find this angle B first. So I'll say that's equal to the sine of B over 150. All right, so now cross multiply. So I'm going to do that on the calculator. So if I'm trying to solve, solve the sine of 69 over 250 is equal to the sine of B over 150. I solve for B. Right, the calculator will do that for us, but I don't want to. I want to make sure you know how to do that without the calculator. Now it's giving us weird answers because we know that there are like an infinite amount of values for B that work. All right, so let's do this without the solve. All right, how would we do this? We would cross multiply. We would take the sine of 69 and multiply it by 150. Cross multiply. All right, and that would equal. So if I did the sine of 69 times 150, that would equal 140. All right, and we would also set it equal to 250 times the sine of B. So now I'm going to take that and divide by 250. So now I have the sine of B is equal to 0.5601. And we know from solving trig equations that if we don't limit B to be between like two different types of angles, then there's infinite amount of answers that you could plug in for B that would work. But in this context, B is the angle of a triangle. So it can't be less than 180. It's got to be it's got to be in between 0 and 180. So I have to find the angle between 0 and 180 that would satisfy this. So I'm just going to do the sine inverse of 0.5601. Oops, I didn't do sine inverse. I got to do, come on, sine inverse of this ratio here. I get 34 degrees. Now, we know that there's also an angle in quadrant 2 that would satisfy this equation here. So if I did 180 minus 34 degrees, 0.0661, we would get 145. All right, so the sine of 145.934, right, also works here. And that's why it's ambiguous. But if we think about it, we know that it can't be 145 because this angle A is 69 degrees, and it's across from 250. Angle B is across from a smaller side than 250. So angle B should be less than 69 degrees. So that's how we know that it's got to be 34 degrees. All right. So when you're solving like this trig equation here, realize that there's an infinite amount of angles that work for angle B. So just by doing the sine inverse, you're finding the reference angle of that angle, and then figure out for this triangle which angles would make sense. And to have an angle greater than 69 degrees for angle B wouldn't make sense. So you're only going to find the angles greater than 0 because it has to be an acute angle if it's a triangle, but also less than 69. I shouldn't say acute, I should have said a positive angle. And so we get 34. So now we know that this angle here is, I'll just round it to 34 degrees. So then you can add up 69 and 34 and subtract that from 180, and you get 77. And then now you could do the law of sines to find this last side. And I won't go through the whole thing. I'll just do it on the calculator. But you would do the sine of 77 over side C is equal to, and then use the two sides that you were given originally. The sine of 69 over 250. Right, then you would solve that equation. And then you should expect side C to be bigger than 250 because angle A is 69 and the side across from that is 250. So side C is going to be larger because it's across from a bigger angle. All right, and then if you have a class, you could do solve the sine of 250 over, the sine of 69 over 250 is equal to the sine of, what did we get, 77 degrees? Yeah. Divided by side C. We're going to solve for C. When you're solving for a side, you're not going to get an infinite amount of answers. You get 260, which makes sense. Always do like a mental check. Be like, would that make sense? And it does, because we know that in a triangle, the biggest side is across from the biggest angle. So there should be the biggest side. But it also should be sort of close to 250. All right, so that is the law of sines. So for homework, all right, I just picked 7 problems for you to do right here. And we have a test tomorrow, so you don't have to do this tonight. You could do it now in class if you want, but it'll be due for the class after the test. So it's due on the 15th. So you have a couple days to do this. So don't feel like if you're studying tonight, you have to do that. All right. See if this recorded.